on YouTube.
All right, good morning, ladies and gentlemen. Today is the 30th. Despite what the board says, I haven't changed that yet. Today we are working on composition of functions. I want to remind you that you will have a review day on Monday, and you have a test on all this material on Tuesday. Tuesday, February 4th. That's definitely something you should put on your calendar. So today we're talking about composition of functions. And a composition of functions is where we're going to take one function and actually put it into another function or into itself. It's kind of like a turducken. You got a chicken stuffed inside a duck, stuffed inside a turkey, right? A turducken, right? You've heard of that, right?
Yeah.
Okay. So that's what we're doing. We're taking a function and stuffing it into another function, okay? But to review from yesterday, we did some function notation yesterday. And I have two functions. I have the f function and I have the g function. And they are equal. X plus 4 is equal to f of x. And so this notation says, hey, what can I replace g of x with? Oh, whoops, my color. Look at me. I'm trying to be all cute. Okay. What can I replace g of x with? 2x minus 6. See, I did the same thing. You got to pay attention. That's what that is. 2x minus 6. And then we need to subtract. And this was subtraction. We wanted to be very careful. We want to subtract the entire thing. What can I replace f of x with? X plus 4. And with subtraction, what did we need to do with our negative? Distribute it. Yeah, so we do want to carefully distribute. So we have 2x minus 6. Negative times x is negative x. Negative times 4 is negative 4. And then it's just combined like terms. 2x's minus an x is x. And negative 6 and negative 4 makes negative 10. And there's our result in terms of x. Number 2, we're multiplying the two functions together. So what can I replace f of x with? Yeah. And again, we want to be very careful and put that whole thing around parentheses because we want to multiply it to the g of x. And what can I replace g of x with? 2x minus 6. And now we just get to multiply, and that means distribute. Got to multiply them all together, not just the 4 and the 2 together. So I'm going to multiply x times 2x gives me 2x squared. X times negative 6 gives me negative 6x. 4. Yeah, 4 times 2x is positive 8x. And then 4 times negative 6 is negative 24. Okay. Combining like terms, we get 2x squared plus 2x minus 24. No, it's unnecessary. But you could. It's not wrong. It's the same. It's equivalent. All right. And the easiest part here, f of x divided by g of x. What can I replace f of x with? X plus 4. And then what can I replace g of x with? Yeah, and that's just over 2x minus 6. And that's it. Very easy to do. If I asked you, hey, what's the domain of this function? Where does the domain come from? Set the denominator equal to 0. Denominator domain, 2x minus 6 is not allowed to be 0. We're going to add the 6 and divide by the 2, and that will give us domain. Denominator domain. X is not allowed to equal 3. Okay. Denominator domain. Denominator domain. X is not allowed to equal 3. A good thing to remember for your test on Tuesday. You might want to put a star or highlight that or something because I will ask that of you. Okay, denominator domain, denominator domain. All right, so that's what we did yesterday. And today we're composing functions, stuffing one function into another function. So here we go. Let's see that. Write this down. This is the notation. So a composition, we see F, circle G. It's not an O. This is the symbol that means to compose the functions. And I much prefer writing it this way. So we're going to see this notation today, but I'm always going to translate it to function notation like this because I think that it makes more sense. It's also easier to follow notation-wise. So anytime you see F circle G of X, we can replace it with F of G of X. And then you can see we have a G of X function inside another one. So example 1, given F of X equals X squared minus X, and G of X equals 2X, and H of X equals 3X plus 4, find all of the following. Okay, so first we have F of G. I'm going to try to color code as best I can here. And, you know, if you have colors, then color coding is always a good thing to do in notes. It helps later. Let's say that that's red. I'll make G of X, or sorry, blue. I'll make G of X red. And I'll make H of X green. There we go. All right. So if I want to do F of G, then F of G means the same as F of G of X. So that is F of, and then on the inside is the G of X. So my G of X is red. Okay. So I'm always going to rewrite this. I think you should too. Okay. Because we can see then order of operations says we have to work inside the parentheses. So we're going to figure out what this is inside first. What can I replace G of X with? Yeah. So that's going to be F of, and I'm replacing G of X. It's equal to 2X. It's the same as 2X. Then what happens is this is now function notation. This is what we've been doing for the past 2 days. It says, hey, go to your F function. But I'm not using X's anymore. What am I going to use instead of an X? Yes. So what should I write for my function? 2X being squared minus, what am I replacing X with? 2X. You see what I'm doing there? No. So this said, hey, go to your F function. There it is right there. But it says, I don't want you to use plain old X. What do you need to use? Instead of X, 2X. So you're placing 2X everywhere we have an X. So instead of X squared, it's 2X being squared. And then instead of minus X, it's minus 2X. So remember, this means replace X with 2X. Use 2X instead. What is 2X quantity squared? Yeah, that's 2X times 2X is 4X's squared minus 2X. And that's it. That's all we can do. That is our composition. So it's really understanding function notation some more. All right, H of G means H of, and what's on the inside? G of X. That's h of g means h of g of x. And again, we need to start inside. So I'm going to leave the h alone for a second. What can I replace g of x with? Yeah, g of x is the same as 2x. So now what does h of 2x tell you to do? Plug in the 2x into the h function. Plug in 2x to your function. And so I have 3 times what? Instead of x, we were using 2x, and then plus 4. Plug in 2x to your h function. All right, and clean it up. What is 3 times 2x? 6x. And then a big plus 4 on the outside, and we're done. I like this. Good. Yeah, your work today is pretty simple, so that's good. Pretty easy. All right. Here we have h of h. What do you suppose that really means? Yeah, so we have h of, and then h of x on the inside of itself. All right, this is h of x is what that translates to. What can I replace h of x with? Yeah, so this is h of 3x plus 4. Now, what is 3x plus 4 telling you to do? Plug in 3x plus 4 into itself, which is weird, but we can do it. So I'm going to write 3 times what? 3x plus 4, and then plus 4 on the outside. So we're placing x with this whole 3x plus 4. All right, and what do we need to do with this 3 then? Distribute it in this case. 3 times 3x is 9x. 3 times 4 is 12, and then plus 4. 9x plus 16. Very good. All right, raise your hand if you're pretty good. You're like 60% good or more. 60% good. 95%. Well, that's good. We're going to do 2 more here. Because one is different. So which one's different? B. Yeah, this is g of h of 2. Which means what? Yeah, replace the x with a 2. Very good. So here our answer will be in terms of x. Where here we're actually going to put it in terms of 2. So plugging in a 2. So example 2, given f of x is x squared minus x. And g of x is 2x. Oh, these are the same. Okay. Oh, that was smart of me. Okay, so you don't have to rewrite these because they're the same. All right, so we want to do the following. All right. So we have f of h, which means f of, what's on the inside? H of x. H of x is on the inside. So again, we need to start on the inside. What can I replace h of x with? 3x plus 4. Very good. All right, so we have f of 3x plus 4. And now what is f of 3x plus 4 telling you to do? Plug in what? Plug in 3x plus 4 into our f function. So what should we write if we're plugging in 3x plus 4 up here? Good. 3x plus 4 quantity squared minus parentheses. Very good. 3x plus 4. Very good. That's pretty tricky because we are subtracting that whole big thing. That's 3x plus 4. Anytime you subtract, you want to make sure you put parentheses around it. All right, so this is where it's a little bit trickier here. This is 3x plus 4, quantity squared. What does that mean? There's 2 of them. Very good. It's 3x plus 4 times 3x plus 4, which is a lot of distributing. So please be very careful. Then we also have this minus 3x plus 4 minus the quantity. What do we have to do with this negative? Distribute the negative as well. So we'll do that as well. But I'm going to go ahead and multiply all this together. First times first, 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x, another 12x. And then 4 times 4, 16. Very good. We're also going to distribute our negative. Negative times 3x is negative 3x. Negative times 4, negative 4. So be careful. This is called a binomial, 2 terms squared. So binomial square. That's always very, very tricky. So take your time with that. We have a 9x squared. I have 12x and negative 3x. Plus 21x. Very good. Positive 16 and negative 4 plus 12. So there's our answer in terms of x is what that means. In terms of x. And we can see that we have some terms with x's in them. Okay, that's a literal statement. It took me, I don't know how many years to figure that out. So that's why I say it so often.
So what's the point of the x in the outside?
So it's just telling you what your answer should end up with. So it's going to end up with x's. All right. Last one here, we have g of. So that's going to be g of. And what's on the inside? H of 2. Very good. G of h of 2. This one's numeric. We're plugging in a number this time. So that 2 means plug in a 2. Where do we plug the 2 in? Yeah, so we're going to go to our h function and plug that in. So right now I'm not touching the g. We're working just here on the inside. So this says go to the h function and plug in a 2. So that's 3 times 2 plus 4. All right, we want to simplify that. Well, 3 times 2 is plus 4 is 10. Very good. So we simplified that to get 10. And now what is g of 10 telling you to do? Plug in 10 into that g function. So what should I write?
2 parentheses 10.
2 parentheses 10. Very good. And what is that? 20. And we got a numeric answer this time. How come we didn't get x's? Yeah, because we gave us a number to plug in. We didn't have an x to plug in or an x to use and end up with. All right, do you guys have any questions for me? All right, cool. You guys have